for the mini-unit, piecewise functions, it's all we're talking about piecewise functions and special types of piecewise functions. These are things that don't fit someplace. Like, it would make sense to do these when you do linear equations, like in Algebra 1, but then you're so busy trying to figure out how to do a linear equation that doesn't really fit. Or then in Algebra 2, you're doing all sorts of different types of things, like quadratics, linear, exponential. So you could do it then too, but you're trying to do so much in Algebra 2, it doesn't really fit. So that's why it's a standalone, week-long function. It just doesn't fit someplace. It draws upon lots of different types of knowledge, but it's not super difficult, and you're going to be fine. Okay? A piecewise function, all it is different equations on different intervals. That's all it is. So you could have 3 different separate lines on your graph, but they're at different intervals. Okay? So I said you can't use a graphing calculator on your quiz, so I'm going to do this using tables of values. I think that'll be the easiest way for everyone to understand what I'm doing. Okay? This is way less difficult than trigonometry. All right, so your first example. This is a prime example of a piecewise function. I have 2 different functions on 2 different intervals. Okay? I'm going to make a table of values to make sure I can graph this. That's all I'm worried about. So, an X and Y chart, just a coordinate chart. Okay, so if you look at your 2 equations, I'm going to start with the one at the top. And it says that y equals 2x if x is between 0 and 4. The symbols indicate that they could include 0 and 4 as well, right? So in my table, I'm going to use numbers 0 through 4. I can't use any other numbers because it's not in an interval. I could use decimal values, but I can't use like -3. I can't use 10. I'm only allowed to use numbers 0 through 4. All right, so then we're just going to plug it into the equation. So what's 2 times 0? And what's 2 times 1? And what's 2 times 2? And 2 times 3? And 8, and so forth, right? Do you need a calculator for that? No. So now we're just going to graph it. Now, when you're graphing it, it's just graphing a line, no big deal, but it's on a specific interval. It doesn't go past that. So it has endpoints. It's just a segment. It's not a continuous line. You have to make sure you're careful about what kind of points you put on your graph. Right, you're going to have solid dots or open circles depending, like you do with inequalities. Again, this is drawing on lots of different stuff you already know. So, yeah, so we're going to have a solid line, and we're going to have solid points at the end of each. So we're going to graph this 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. I'm going to connect those dots, but again, it does not go past that. It's just a line segment. Does that make sense? Yeah? Okay. For the second interval, you don't have to. I'm going to make a table anyway, just so that everyone's on the same page with me. It says y equals 8 if x is between 4 and 7. Now, I know it says it's not equal to 4, but you always need a starting point. So you're going to use that 4 anyway in your table. We're just going to have an open circle later. Okay? That's fine. So 4, 5, 6, and 7. Right? Now, the equation says y equals 8. Not 8x, just y equals 8. So that means y is always 8. What should this part of the function look like? A horizontal line, right? All right, so we're going to go up here and graph this. We'll graph this one in red. So at 4, we're supposed to have an open circle. Notice that's already filled in there, though, right? That's okay. You can leave it filled in. It's fine. You can if you want to, but you don't have to. It's not necessary. It's like a connection point. So then you have 5, 8, 6, 8, 7, 8. And at 7, 8, it's also a closed circle, right? And we just connect the dots. That is the function right there. That is it. You can, but it's super complicated. Yep. They don't have to meet. The two that I'm doing an example today, unintentionally they all connect. They don't have to connect at all. Like I could have a line here and one over here. Like they don't have to meet. Okay, so I want to talk about something with this one before we finish. We know what the graph looks like, and that's awesome. It's pretty, great, wonderful. You don't have to graph these if it's just wanting you to find specific function values. So remember function notation? Does that ring a bell? So if I wanted to find, I'm going to make up some values, okay? Just for discussion. Okay, if I have these function values, and I don't have the graph, I don't have to have the graph. These are all x values in the parentheses. So if I'm trying to find what y is equal to, I don't have two answers. I'm only using the function where my x falls in the interval. So if I didn't have the graph and I'm trying to find f of 1, does 1 fall in the top interval or the bottom interval? The top one. So I do 2 times 1, and I get 2. I don't get 8, because 1 is not in that interval. Okay? What about 4? Which interval is 4 in? The top one, right? It's not equal to 4 in the second one. So it would be 2 times 4, and that equals 8, right? What about 20? Is 20 in the interval? It's not in any interval, so this actually does not exist. There is no graph at x equals 20. There's nothing there. It stops. Right, yeah, there's 2 line segments, and they're both, they just stop, right? There's nothing going on to infinity. Let's do one more. What about f of 5.5? What interval is 5.5 in? The bottom one. And so the bottom one just says y equals 8, so the answer is just 8. Yeah, but it'll work. Does that make sense? Okay. Then moving on to the next one. Is everyone okay with that concept, though? They're just putting lots of stuff together you already know. So that doesn't really fit anywhere. Like, it's stuff you know, more stuff you know, and you got to put it all in the same place. All right. Second one. We have 3 different functions here. So I will make a table just so that everyone sees what I'm doing. You don't have to make a table. It's not absolutely necessary, but I think it's helpful, especially if you're not using a graphing calculator, that you don't mess it up. Yeah, we're doing the second example. So the second one, the first one we're looking at says y equals 6 if x is less than or equal to negative 6. So I need to use negative 6. It's one of my boundary points, so I need to use that. And then what other numbers could I use? Less than or equal to. So, right, negative 7, negative 10, for example, right? And it just says that y equals 6. So all of the y's are going to be 6. So again, this should look like a horizontal line. Yes. Yes. You sure? So we have a less than or equal to, so we have a solid point at negative 6, 6. I was counting, I'm sorry. And then it says less than or equal to, and so that goes on forever. That has an arrow. I intentionally have a line with an arrow. It's just less than negative 6. It's not bounded by 2 numbers. Does that make sense, that it has an arrow? Good. Can I erase this part of the table? All right, the next one. Actually, let's do the bottom one. It's almost the same thing. It says y equals 6 if x is greater than 6. So I do want to use 6, even though it's not going to be a closed point because it's my boundary. So what other number should I use in my table? 7, 8, 9, etc., etc. So 7. Yeah, I skipped the one in the middle for a second. So again, it says y equals 6, so all these are just going to be 6. So the point at 6, 6. But it's open. And it's all numbers greater than 6, so it has an arrow. You can. I can, sorry. So far, so good? Can I erase the table? It's not dotted. There's an open circle at the end. I was just putting the points from the table on there. All right, and then the last one is this one in the middle. What kind of function is this? Absolute value, right? Again, stuff you've seen before. We're just putting it all together in different capacities here. So this is from if x is between -6 and 6. Well, if we're looking at our x size, it can be -6. I'm going to skip a few in the middle, right? Any number between -6 and 6. Everything between. So, between what two lines? Oh, yes. Sort of, yeah. So at -6, what's the absolute value of -6? What's the absolute value of -3? Absolute value of 0, 0. And we have 3 when we have 6, right? So if we're going to do this, be careful. You have open circles for both of these boundary points. So the first one at -6, 6 is already filled in. So I'm going to leave it filled in because it's already filled in. But then I have -5, 5, and -4, 4, and all of these in between. But then at +6, there's an open circle, and there's still going to be an open circle. There isn't on either of the boundaries. It doesn't have a greater than or equal to or less than or equal to. Yes. Yes. No. So again, like I did last time, if I asked for some function values, if I asked for f of -22, f of 7, f of 6, f of 0. What's f of -22 going to be? It's the top one. It's less than -6. It's going to be 6. It's going to go with that one, right? What about 7? Also 6. It's in the bottom function, right? What about at 6? It's not included in any of them, so this point does not exist. It's like a hole in our graph. It's a hole. And then what about at 0? What interval does that go into? The middle one, and so the absolute value of 0 is 0. Does that make sense? Yes? All right, I've got one more example. You should also be able to do the reverse. I should be able to give you a graph of simple functions, and you should be able to write an equation for me. Okay? So here is a graph, and you're going to write me the piecewise function. So we got to start with f of x. How many lines do I have in the graph? So I'm going to have 2 separate functions, not like 3 or 4. I have 2 separate pieces. Let's start with the bottom piece because it's easier. Yeah, so let's start with the boundary because the boundary is always pretty easy. The boundary goes from what x value to what x value? -2 to infinity, right? So all x's are going to be greater than or equal to or just greater than? equal to, this one's actually shaded in. Look at the one above it, it's not shaded in. It should be darker, I didn't make it, I'm sorry. So all numbers greater than, x is greater than or equal to negative 2. What is the equation of that line? Negative 2. Y equals negative 2. You can't put if or a comma. So far, so good? All right, let's do the interval for the second part, and then we'll talk about the function. What's the interval? Looking at the x values. Negative 2 to negative infinity. Does it include the negative 2? No, so if x less than negative 2. Yes. One second. We're going to talk about it. You're just looking at the x-axis. Yes. All right, so for the function, this is a linear equation. What is the slope of this linear equation? 1/1. So we know it's going to be x, right? But what does every equation need to have? A slope and a y-intercept. Now, the y-intercept isn't actually part of this graph, but it is part of the equation. So if you need to extend this back a little bit, you can. What is the y-intercept? Positive 5. 1, 2, 3, 4, 5. So the equation is x plus 5, even though that plus 5 is not going to be on the graph. So that's pretty much the first learning target in a nutshell.